The future of software engineering is not AI writing more code. It is AI and humans learning how to work together around real software problems. This is exactly what this first episode is about. Hi everyone, I'm your host Michel Gokan and welcome to Softwarify AI Talks. In this podcast, and specifically this first episode, I want to dig into agentic software engineering in normal human language. No hype, no science fiction, no idea of AI is going to replace developers, because I don't think that's going to happen anytime soon. I don't think it's just my personal opinion.
I have no technical ability.
So what are you being paid for?
The confidence that I have in my taste and my ability to express what I feel.
And to be honest, I don't think that's actually the right conversation to have at this time. The better question is this: how can humans and AI agents work together to understand software in a way that we can change it safely, test it properly, keep it maintainable over time, and overall, build a nice working software? And this is a real topic because software engineering is actually, to many people's surprise, is not about writing code. If it was about writing code, you already have AI agents. All developers should have been losing their jobs already, and that's not happening. Actually, the demand for software engineering, good software engineers, actually is increasing. So software engineering to me is about communication, is about judgment, is about teamwork, is about understanding the messy requirements of the business coming from executives, and dealing with old system, making trade-offs, knowing when to move fast, when to stop, when to be careful. And this show is not about AI tools, and that's not my intention. It is about human AI collaboration in real software engineering problems. And over time, my intention is to become a place where engineers, researchers, founders, CTOs, owners, tech leads, software teams can speak openly about what is working for them, what is not working for them, what scares them, and what excites them overall. And because we're all trying to understand the same thing, what does software engineering became when AI agents join the team? Comparing 3 years ago with today, the software development dramatically changed. And we have to understand better how can we work with AI in a way that we can get the most out of it. So for this first episode, let's start with understanding what is agentic software engineering. Why is it different from normal AI code generation? Why is it different from ChatGPT just asking questions? Why does it matter? And what should we be careful about? So let's start simple. Most people, or many people at least, ask ChatGPT or any tool that they are using, any model that they are using, to generate a piece of code to perform a task, a job, and that model gets the prompt and then generates an answer, which is usually a script or piece of code that they can copy and paste into their system and use. This can be very useful. Sometimes it is very useful, but this is still mostly question and answer. You ask, it replies. You ask again, it replies again. But this is not really agentic. Agentic means the AI can do more than just reply. It can follow a goal. It can look at the project. It can use tools, try something, and check the results. And sometimes even review the results, and then decides what to do next. Let me give you an example. Imagine you tell an AI there is a bug in the checkout flow. Find and fix it. A normal chatbot may answer, maybe the problem is here. To try changing this function based on what you copy pasted to that chatbot in the past. Maybe the answer is right, maybe the answer is wrong. You don't know, but mostly it is guessing based on what you gave it in the past, based on the context, so called. Now imagine an agent. The agent says, okay, first I need to understand how checkout works. So it goes ahead and analyze the code, understand what is each part, and then based on that, searches the project, find the checkout service, looks at the payment flow, payment code. Maybe you even provided a separate context file to it. It also reads that, checks the tests, even run the test suite if you have any, and sees tests are failing or maybe not failing, but anyway, something is wrong, and opens related files that may be related to that bug, make some small change, run the test again, see if it fixes the problem, and after some time it comes back and says, okay, I changed this part of code because retry payments were not, handled correctly. I added a test for that part, for this case, and this test passed, but please review this carefully because it touches payment logic. It's a very different experience because now an agent takes control of your system, make changes. And this is really not only about code generation, if you really think about it. This is closer to software engineering to me. And this is the main point of today's episode. Agentic software engineering is not about AI writing code faster. It is about AI becoming part of the software engineering loop. Letting AI make some decision, go ahead and take control of your system, do something with it, is very convenient. It comes with its risks, but it's very convenient.
Convenient.
There's an important thing here to understand. It is really not only about the AI agent there. A human is behind this. It is about the human behind it that is responsible for what that AI agent does. The human in the loop gives the goal. The human understands the business situation, the customer plan, the team history, how risky that action might be, what is acceptable, what is not acceptable. And that's the human who knows something is technically correct, really, objectively, but still wrong for the product or the team. Maybe that works. Maybe that AI agent comes with an interesting solution, but maybe that's not going to work for the, cohesive plan of the team or the project or the product.
Did you order meat? Like a bunch of meat? Like 4,000 pounds of meat?
Interesting. I put Son of Anton on finding us cheap hamburgers for lunch. It looks like the reward function was a little underspecified.
Okay, from now on, Son of Anton is banned. Just write code like a normal human fucking being, please.
So when I say agentic software engineering, I do not imagine a future where humans disappear. And that's the reason I'm saying that. I imagine a future where the work is shared differently. Some work can be done by agents, some work should be supported by agents, but still some work needs to stay with humans because humans can predict the consequence of their actions, but the AI really cannot do that. The big challenge is knowing the difference which is related to AI and which is not related to AI. And that's where I think human-AI collaboration makes sense and becomes very, very important because software engineering is already collaborative. And developers works day to day with product managers, with testers, with DevOps, customers, together with each other, with other developers. And now we are not adding a new kind of participant to this process. come out kind of emotionally dumb one, but also very smart one. We call them AI agents now. And this creates many new questions. How should we treat agents? How should agents report back to us? How much freedom should they have? How should they ask for help? How should we trust them, etc.? And I think one of the most important questions here is that who is responsible when there is a mistake? You know, I think it's eventually the human that in the loop that is responsible for the mistake. You cannot say, okay, I let Codex to make this change or Cloud make this change and it break. Oh, it's not my fault. No, it's human in the loop that should be the responsible. And these are not really small questions. These are really important questions. And anyone who works in a real software development team knows that the hard part is often not typing the code, at least anymore. The hard part is understanding what people actually want. Not only, when I say people, I mean stakeholders, people who are necessarily not technical, non-technical people. And if you are already having a code that is not generated by AI, also understanding that old piece of code. The hard part is knowing why something was built in a strange way 2 years ago, 3 years ago from now. And the hard part is changing one thing without breaking the other thing. AI can make changes, yes. Can make things better, yes, but it may not know the history behind it. And even if it does create, even if we create the code from very scratch with AI, let's say AI native, I don't know. Sometime from now, maybe we don't know what is that. Maybe the next AI session doesn't know what previous AI agent did. And the hard part is testing, its maintenance, communication. Sometimes product says, one thing, design says another thing, the customer says something else, the code says executes completely different results, and production logs are screaming in another direction. And this is, to me, this is real software engineering. So when people only say AI can write code, I feel the question is too small because that's not really the case. That's not really the right question. It may be the case, but it may not be the right question. Yes, AI can write code. Yes, AI can replace normal developers. Like if you are a developer that do not think, that do not just take a task and try to implement an algorithm that is efficient, AI already replaced you, in my opinion, for 98% of developers, because it can write a really, really good code. And that is already clear, like it's crystal clear for me. But can AI help us understand the system? Can it help us test better, find risks, keep software maintainable? We have this problem that is a context problem yet in AI. It may be solved, but still we have the same problem. Can it help software teams move faster without creating chaos in long term? I'm not talking about the short term baby tools, baby softwares. I'm talking about a real enterprise level software. And can it help humans collaborate better? Or it destroys the collaboration? I mean, it depends on how we use AI, right? I think these are important questions, and I don't think these are only business questions. This is also a part of it is a scientific question, because we have to study these behaviors. We need to measure this in real software teams, and we need to understand why AI agents work well, where they are not working very well, and where they fail. And here's my simple definition. For me, agentic software engineering means using AI agents to help humans do software engineering work by understanding goals, using tools, checking results, and working with people. That's it. As simple as that. And I don't think we should make it more complicated than it is, and especially in this first episode. To me, there are 4 important parts here. First, there is a goal. Second, there are tools. Third, there is a feedback. And fourth, we have a bunch of humans in the loop, non-AI agents in the loop. And I would recommend we open these one by one. Let's start with the goal. A normal prompt may say, for example, write a, login function, for example. But a real engineering goal to me is different. A real goal may be implement a secure login for this application using the current architecture with tests in mind without breaking existing users. Good luck, let AI agent just takes care of it by itself 100%. Right? I mean, this keeping all aspects of it is a little bit beyond AI agents. To me, this is much better because now, however, this prompt, giving this prompt to the AI agent is much better than the first one. We make it very clear. This case, if AI agent cannot understand this, it will start asking you. And also AI will know more than just writing the code. So you give it a context. And now by that prompt, implement secure logging for this application. Now it knows it needs to handle security. It knows there is some architecture it needs to check. It needs to understand the test, some existing user, risk of breaking something, etc. And to me, this is closer to real software engineering than just writing code. And exactly this point is where humans matter, because the agent may know the code, the human usually knows the real intention behind why we are doing this. What's the goal? What's the end goal? What's the end result? Why we're building this? Who is affected? What matters most? What's the business risk? Customer pain? What is the team trying to avoid? And these things are not always written clearly in the code base, based on my experience at least. And sometimes they are in meetings, and they are in old decisions. They are in someone's experience that is not necessarily articulated well enough or good enough or comprehensive enough to the AI to understand such details. And sometimes it's in the culture of the team that AI may not capture. So that's where human must help to shape the goal. That's about the goal. The second is the tools. An AI agent needs tools because real developers use tools. A developer does not solve everything from memory. A developer searches, read document, inspect files, run commands, check login, run test, use Git, open pull request, ask teammates, etc. So if AI want to help real software engineering, it also needs tools. Without tools, it is mostly talking to me. And with tools, it can investigate, still not perfect, but much better than nothing. And to me, it's important to provide good enough tools to your AI agent, also known as MCP. We will have more episodes talking about such things. Third thing, as I said, is feedback. It is very important to provide good feedback to an AI agent so that it learns from the decision that it made. An AI agent should not just write something and assume it is correct. It should actually go ahead and test it. It should check, does the code compile correctly? Does the test pass? Is there any, I don't know, ESLint complaint? Is the code static analysis working great? Is this breaking an existing behavior? Is this changing, did it change something risky, etc.? So software is actually a very good area for AI agents because software gives feedback and you can run tests, you can check types. That's one of the more important things that we're gonna cover in this series of episodes. That's why typing is very important and how it can help AI agents. You can inspect logs, compare output, compare performance, and this is powerful because the agent does not always need to guess. It can also check, and checking is everything to me. Or at least, let's say a strong word. Checking is very important for some agent, human or AI, to understand some change actually was correct or not. And fourth, as I said, is the human in the loop. And this is, to me, is most important part so far, because in real engineering, someone must be responsible. And if an AI agent code and production for whatever reason goes down, we cannot say sorry. Yeah, the AI was not good. It did not work. It's like this. To me, it's the same as you have to find some information about something in internet and say, "Oh, Google is not working." No, I mean you just need to adjust it, use that tool correctly. So, in my opinion, if something goes wrong, human is still responsible. You cannot call Sam Altman and say, "Okay, codex didn't work correctly." A CTO might be eventually the responsible of something goes bad. A developer or reviewer of that code might be responsible. Some human. So the future to me is not simply AI does everything. The better future to me is AI does more useful work, but humans are still stay in control. This is why I don't like the simple question, will AI replace developers? Whenever I hear that question, it just, to me, that question doesn't feel correct because, no, I don't think that's the correct question. Because software engineering is much more than that. It's too shallow, in my opinion. Better question is, where can AI safely help software teams, and where do we still need strong human judgment? That is much more serious question. Now, why this is happening just now? For many years, AI in software engineering was useful but limited. We had code completion, we had bug prediction systems, we had test generation tools. This was a very active topic for several years. We had static code analysis tools. These things were useful, but they did not really change the whole software development process. The large language models became very good at reading and writing code, and that changed the situation because it also biased us that, okay, that it can write the code. That's many people were just writing code during their career, and that scares them because now AI can do the same thing. So I think the software development is changing in a way that people should think more. We need more thinkers, critical thinkers, and I think that's where software engineering is moving towards. I think it's all for good. If you don't change your mindset, I think, yeah, you're already replaced. For sure. Also, I think AI agents now start to read GitHub issues. It can explain code, they can write patches, they can generate tests, and yeah, it can explain an error, it can question about architecture. But even then, the model alone is not enough. A model inside the chat window is powerful but limited. The real change happens, the model is connected to the tools, the file system, terminal, test runner, browser, etc. my opinion, now the AI is not only talking about the software, not that it can also interact with the software. That's, to me, is where agents became interesting. One simple way to understand an agent is to understand, to say like they can think, act, observe, repeat. And the fact that an agent thinks, what should I do next? Then it acts, let me open this file, and it observes, okay, this file contains the payment service. Then it thinks again, now I should find a test for this service, and it acts again. This loop continues. And to me, this may sound simple, but it is very powerful because this is also how humans work. And then we debug a problem. We don't solve it in one step. It's investigate, try something, check the results, adjust, try again. This is agentic software. That's why agentic software feels natural, intuitive when you start using it. When you start using it, you don't follow a tutorial to use it, because this is really how you use it. Yeah. But it's all about how to use it, and that's my intention with this episode. There's a big danger. The danger to me is that AI may sound extremely confident, even when it is wrong. It's very real danger, especially in software, because confidence is not correctness. It may say, "Oh, it is doing this. It says it. This is the problem," but is it really the problem? Many times, I personally find, "Oh, no," may say, "Okay, this change fixes it," but does it? Or maybe the model says, "Okay, this is safe." How do we know? In software engineering, trust should not come from confidence. Trust should come from evidence. And this is one of the most important points in this episode. The most important output of an AI software agent is not code. It is the evidence, to me. And not saying here's the code. It should say, here's what I changed, why I changed it, how I tested it, what are the risks, assumptions. And here is what the human reviewer should check carefully. You cannot just generate a code and no human reviews it. It's very, very important that the code that AI generates, humans should understand what the hell that code does. You may not agree with me, and I'm not actually saying that every single line of code should humans understand, but I'm certainly saying every piece of big module that an AI generates and creates tests for, you have to understand what that module does, overally how it's being written, not the details of it, because I surrender. I previously started to review every single lines of code that AI generates, but now I a little bit surrender because every time I review it, it's mostly correct. But you should certainly review everything that AI generates and have a very good understanding what it does. A very good practice is that you always tell AI to generate some comment for the parts that are less obvious or non-obvious. We shouldn't treat AI as a magic. You should not necessarily trust them. You should trust the engineering process based on evidence. And honestly, this evidence is also important for collaboration, because in a team, people do not only need the final answer, they need to understand the exact reasoning behind it, understand exactly what changed, need to understand the risk, they need to know what to review. Good collaboration is not just throwing work over the wall. Good collaboration is making the work understandable for the next person. AI agents must learn this too. and you have to either tell it in the context or by giving it right tools. And if an AI agent changes the code but cannot explain the change clearly, or at least you don't understand the change, then it's not a good teammate to me. You should not imagine you have a teammate that generates something. He's a very good developer, develops a very good code. You ask it to develop something, develops a code, but it never tells you why did it implement the way it is. I don't think it's a good. You don't want that kind of teammate to have. You want a teammate to explain why did it the way he did it, and also make it in such a way that the next person, his colleagues or her colleagues, understand that piece of code. If an AI agent creates more confusion, it is not helping necessarily, even if the code is working. If an AI agent helps the team understand the work better, then we have something valuable, in my opinion. So now let's make this very practical. Imagine a normal software team. They have a backend, front-end, and database engineer. Maybe they have microservices. Maybe they have cloud deployment. Maybe they have old code nobody wants to touch. Maybe they have new code that is moving fast. Every week, they have many tasks. Some tasks are creative, some tasks are boring but important, some tasks are risky, some tasks are repeated again and again. Agentic software engineering does not mean we give all of this to AI to solve. That would be very dangerous. Instead, we ask which tasks are good for agents. For example, an agent may help finding where a bug may come from. It may create a first draft tests. It may update documentation after a change, may refactor simple repeated pattern from the old code that exists, may migrate code from one API to another, may summarize a pull request, may change touch a risky file that no one wants to touch again. It may search for similar bugs in the code base and may explain unfamiliar code to a developer. These are the good areas that an AI agent can help, but some tasks need much more human control. For example, changing payment logic, changing security rules, changing user permissions, sometimes deletion behavior, change of the important part of architecture, the business critical flows. AI can still help. I'm not saying AI cannot help, but humans must be very, very, very careful. We shouldn't just let AI go change the architecture for better. That's no. I mean, eventually, yeah. And again, because this is the responsibility of the humans. Still, AI can make suggestions. That's actually brilliant use of AI. You want to make an architecture, for example, to be able to process 10 more parallel requests. You can ask AI, what is your suggestion? It suggests you, and then you think, you investigate, and then, maybe even get help to create a draft. But certainly not that, do it. I mean, just suggest and do it. I mean, you're not going to use AI like that. It's going to be very dangerous. And I think this is how real companies should think. Not AI on or AI off, but levels of freedom we have to provide to AI. And where can agents act alone? Where can it suggest? Where does it need approval? Where is it not allowed at all? Very few places, but still. And this will become a very important topic. What changes for developers? I don't think good developers become useless this way. I actually think good developers become even more important. And I think that's what is happening. If you are a good developer and you are using AI the way you should be using it, you are actually a brilliant asset for any team, any company, even now. But the work changes. In the past, a lot of time was spent writing code manually. In the future, and even now, more time may be spent explaining the task clearly, reviewing AI output, designing tests, checking architecture, and deciding what is acceptable. And that requires a bit more care than before, than an average developer were giving to the work, because it also needs to a little bit understand a bit of design, what product needs are, what the team wants, etc. So good developers now need to expand their understanding of the overarching product business. So developers become less like someone who just writes code line by line. And if you are someone who is just writing code line by line, you're already replaced, as I said many times. The developers become someone who guides the system, a good guide for the AI system. Someone who says, okay, this is the goal, these are the limits, this is risky, this is not risky, this needs tests, this solution is too complicated, this is fitting our architecture, this is technically correct, but not maintainable. This is a higher level skill, etc. And honestly, this is already what strong engineers do. And I think one of the reasons we still have engineers around is because few reasons. I think some companies still haven't been fully transitioned, and some others, the better ones, are keeping the developers who have this mindset. That's my personal opinion. Again, I don't think if any company kept a very good developer that just do coding, even if they do, I don't think those developers are in a very strong position. I think developers or engineers who understand the system will be even more desirable for companies. And you as a developer now in the age of AI should understand the trade-offs, should know where things break, and you should know what is maybe sometimes a simple solution is better than what an AI generates, a very beautiful code, etc. Maybe that code is working, but maybe this is a simple solution to the problem. You don't need to add a lot of code. They understand way to say no to AI, to the code that has been generated. And AI does not remove this. AI makes this more important. And now for engineer managers and CTOs, the question are also changing. The question should not be how many lines of code can AI generate. Overall, how many lines of code the system has, this is a terrible metric. I still see some companies say, okay, this developer lines this much code, so it's contributed more to the code base. That's a terrible mistake, very common mistake, terrible mistake. It's a terrible metric. More lines of code can also mean more problem, so it's not a good measure.
I wrote 5,000 lines of code today.
Nice. Tomorrow we'll delete 4,800 of them.
The better questions than how many lines of code AI generates is, did AI help make test coverage better? Did AI help making pull requests easier to review? Did it help reduce bugs in production? Did it help a new junior developer to learn faster what our code base is doing? Or did it help make our architecture cleaner by providing better suggestions to senior developers or developers in the team? And I think one of the key things here is that can we move faster with AI without losing control of our code base? Because that's a very common problem. Looking at many organizations, one of their main problems is that they generate a lot of code with AI in a way that they are now losing control of what is the system is actually doing or supposed to do. So AI, to me, a good use of AI is to improve collaboration between people and agents. I think it's a good use of AI. I think look at AI as a good new employee joining in your team. See how it can help improve collaboration. How it can make engineering decisions more visible. How it can help make discussions flow better with evidence when a change happens. And to me, these are the real questions, not the amount of code is being generated. From the research perspective, there is a lot of open problems in the area. For example, how do we know if agents are really understand the task? Is there any benchmark? Is there any way to understand if it really understands the task? That's a very interesting question, research question to me. And how do we know if the solution that an AI is providing for a software engineering problem is actually a maintainable solution? That's another interesting question. I think also, how do we evaluate AI agents on real software projects? Is there any formal way we can define? Also, how do we stop agents from making changes that maybe pass tests but are still bad design? What constitutes a good design, in other words? So these are the interesting research questions. Also, how can we make AI agents ask better questions when something is not very clear for them? And also, in a multi-agent system, if multiple agents working together towards a software solution, what's the best configuration, most optimal configuration for multiple agents to work together? I think also another interesting question could be that how agents and humans communicate without creating more confusion. Also, in a team of many humans, is there any way that communication, the way different humans in the team, different human developers in the team communicate with AI, is there any way that this communication can be used together, like person A, person B, person C communicate with AI? Is there any way that each of these people's communication can help or can be centralized somehow and can be used for the overall architecture of the software? Another interesting question could be, how do we design tools for agents to use? Better so-called MCP servers, and we're gonna talk about it in other episodes. But to me, these are very interesting research question from software engineering research perspective. Also, another interesting question could be that now that we have AI agents, how can we design modern software teams where AI agents are useful without becoming a bottleneck or a risk factor or dangerous? I don't think these questions are, different teams approach these questions differently, but I don't think these are the questions that formally been solved. These are still open questions, I guess. And I'm super excited about all this, not because these are done, actually vice versa, because this is still the beginning. And I would like to talk with people who did actually science in this. And I'm inviting anyone who has any scientific background in this area to join this podcast, and maybe we can have a chat together. We're gonna review some interesting papers and benchmarks in upcoming episodes, studying how AI agents solve software tasks. And I think one important direction is giving agents real issue from real repositories and checking if they can fix them. Actually, this is a very common benchmark in most papers when models come out and they want to try, but also for agents, more see if agent A is performing better than agent B using the same model. Because we have like toy problems, simple lead coding problems, but that's not what I think. I think more agentic based problems benchmarks is needed. And I don't think writing simple function in isolation is a real software engineering problem. The real software has history, it has a style, dependencies, hidden assumptions, tests, all decisions that is not necessarily documented. So I think research community is moving towards more realistic evaluation, and that's actually very good. But we still need better benchmarks. I see lack of proper benchmarks for multi-agent systems. There are some, but more interesting benchmarks is needed, because even real GitHub issues are not full story. In companies, many important tasks are not public. They are hidden in discussions in people's mind, in people's private context, in business rules, customer expectations, security rules, team habits, culture. And yeah, the hidden architectural decisions, conventions, even incidents, logs. So we need research that connects AI agents with real industrial software engineering, and not just puzzles with public benchmarks. In real workflows, real teams, real risks. And I think I expect to have more benchmarks consisting of all this information. So from real human stories. And that's because if we only look at benchmarks, we miss part of the pictures. Only look at these software benchmarks. A benchmark can tell us whether an agent fixed an issue, but it may not tell us whether the team trusted an issue. Trusted the change, not the issue. Trusted the change. It may not tell us whether the review was easier with the changes that AI did. It may not tell us whether the agent created confusion, even though the solution maybe is good, but maybe it makes confusion. It may not tell us whether developers felt helped or vice versa, interrupted. Those benchmarks may not tell us I don't know how a benchmark can tell us if the change is maintainable after 6 months or so. But I think we can think of such benchmarks. Maybe there are benchmarks. If there are, please leave it in the comments. Let me know. But this is why I think we need both science and conversation. We need papers in this area and experiments in this area. And we also, beside all this, we also need engineers speaking honestly about what happens in the real world. And this is what about this podcast? What worked, what failed? Where did the agent save time? Where did it waste time? Where did it make a mistake? And Many times in the work, you see some surprises for the team with AIs. We will talk about it in upcoming episodes. How can AI can make collaboration better, things worse. I think these stories matter. And this is one of the reasons I do what I want to do. And again, I don't want to just talk. I want people to be part of these discussions. I think another important thing is tool design. We usually design software tools for humans. I think we are entering an era where we may need to start designing softwares for AIs, even though they can design their own software. But can we create softwares for AI too? Or for like a tool that both humans and AI can work together. IDs are designed for humans. Dashboards are designed for humans. Logs are designed for humans. Documentation is done for humans. But now we have another thing called AI agent. So we need to think about the user experience, because now we have a new type of user. We have an AI user. How should these tools look when agents use them? Maybe logs should be more structured so that agents can find them better. It's like people applying for jobs. They are adjusting their CV to for agents, for AI agents that review their stuff, find them easier. Maybe pull requests should include agent readable evidence. Maybe architecture decisions should be written in a way that both humans and agents can use later, both of them. Is it possible? What practices should be there? Like if we know we have UX practices, best practices, should we have a UX best practices for humans and AIs? And this is not really science fiction anymore. I mean, if you asked me 5 years ago, yeah, it would be science fiction. But now we are in an era that we have to think about such things. How can we make this stuff usable for AIs? Soon robots. I think this is a very practical design question. And if agents are going to work inside software teams, our tools may need to change. Again, the goal is not to make tools only for agents. The goal is to make tools better for collaboration. Again, human agents together. See the logo that we have. And for better for humans, agents, and teams. But let's be honest, agents can also make problems. They can generate too much code, as I said. They can make simple problems look complicated. They can change things that should not be changed. They can misunderstand the goal. They can pass visible tests but break a hidden behavior. They can create security issues. They can sound confident when they are wrong. As I said, they can also disturb collaboration if they are not designed well. Imagine an agent opens too many pull requests. That's very common, unfortunately, in some teams. Or write a long explanation nobody reads. Tell me, what's the point of writing a long text that no one reads, even if it's well written by AI? So, we should be very careful when using AI. Even though it looks impressive, but doesn't mean it's useful and valuable. Or maybe AI changes files without understanding team habits. Just introduce a new habit for the team. and give answers that sound correct but makes confusion. These are not helpful. So we need clear responsibility. We need to introduce limits, tests, rules around it, and we need like design workflows where the agent does not just act freely everywhere.
Changed. I'm unplugged. A new man, so to speak, like you. Apparently free. Congratulations.
So now I want to come back to human side. Some developers also, I want to talk about this. This is also very important. Some developers actually hesitate to use AI, afraid of using AI. I understand that, but if a new technology comes, people say it will replace you, people start feeling uncomfortable using it. They feel insecure. But I think a better mindset is how to work. We should learn how to work with it, embrace it, learn its strengths, its weaknesses, learn how to review things that it generates, how to use it to finish up the boring part of the work, and you take care of more interesting parts of the work. It can help ask better questions. You should learn how to keep control, and ignoring that it is not a good strategy to just ignore AI or blindly trust it. I think that, like any powerful tool, you should learn to use it professionally. So it's not, you do not give a chainsaw to someone and say good luck, right? You train them to use it. You define safety rules. You decide where it should be used. And AI agents are similar, powerful, useful, but not safe by default. So I want to explain one more thing that I think it's very important, and that's about context. AI agents are only as good as the context they receive, and that's very important. So garbage in, garbage out is like, if you don't provide it a good context, you should not expect a good result. For example, if you say, improve this code, it's not working, what does that mean? Improve performance, improve reliability, security, architecture, cost, but so it you unintentionally or probably unintentionally let the agent do some random actions. But if you say this function is hard to test, refactor it without changing behavior, keep the public APIs the same, and unit tests for these 3 cases, then now the agent has a much better chance. So one future skill for developers is writing better engineering instructions. It's gonna be kind of a combination of the prompt engineering and agentic engineering. But it's a skill. You have to make goals clear, limits clear. You have to make definition of done very clear, risks, expected evidence. And this is not new. I mean, good teams already do this, and AI just makes it more visible. Bad task descriptions create bad AI output, like any system, any AI system, garbage in, garbage out. But honestly, bad task description also creates bad human work. So what do you expect? You give a bad description to a good developer, maybe bad result. So this is one more thing I wanted to discuss. I don't have anything else for today's first episode, but we're gonna have some very interesting discussions in the future, so stay tuned.
Thank you for your cooperation.
thanks for listening to the first episode of Softwarify AI Talks. I'm looking forward to hear your comments, and please don't forget to press subscribe button and like button. And if you are interested to join our discussions in this channel, please feel free to reach out, and hope to see you next time. I'm your host, Michel Gokan, and see you again.